the quantity of light your objects are exposed to. How? You measure the amount of light each object receives. This is done with a light meter. These are inexpensive meters which read the amount of light in units called foot candles. Paintings, paper, and textile objects which are to be exhibited for a long period of time should receive no more than 5 to 10 foot candles of light. Metal and stone can take a bit more. Finally, you should limit the duration of light exposure. You can use timed lights, draw the drapes in your building on a regular schedule, and avoid any spotlighting. You can determine the amount of light damage to your collection by using these ISO fading cards. These are cards which have 8 swatches of fabric on them. Each piece of fabric fades half as fast as the one below it. These cards can be placed near your object and compared from time to time with an unexposed card to see just how much of the fabric has faded. These cards are very helpful in demonstrating light damage to others who know less than you about the damaging effects of light in your collection. The second environmental factor is actually 2 factors which operate in tandem: temperature and relative humidity. We have already seen some of the effects of high temperature: dehydration, accelerated reaction of deterioration causing yellowing and embrittlement of the object. As we have seen, objects can be overheated by light. Objects can also be overheated by gas and electric heating units and by being enclosed in an attic storage area where there is inadequate ventilation. Temperature determines how much water the air can hold. This is known as the relative humidity. As the temperature rises, the air is capable of holding more moisture. As the temperature goes down, the air can hold less moisture. The net effect of these temperature changes is that as the relative humidity goes up and down, the air and all the objects are constantly responding by losing and gaining moisture. This may seem innocent enough, but there is a very serious problem here. If the humidity gets too high, mold growth can occur. Some molds, as in the case of this book plate, attack iron preferentially and cause these yellow stains. And a high relative humidity creates a water source for all sorts of chemical reactions which may not occur in a drier environment. Very often, these chemical reactions involve the generation of compounds like acids or bases which can attack the object and cause great changes in the structure of the molecules. Very often we see metals with this type of corrosion problem. Here, moisture activated a chloride compound in a bronze sculpture, which becomes a degenerative corrosion problem by generating more hydrochloric acid, which makes the entire process repeat itself. We also see pollutants in the air become acids in a high relative humidity. These acids in turn damage the objects. As the relative humidity goes up, objects absorb this water and begin to swell. This expansion causes a compressive stress on joints and already stressed areas. When relative humidity goes down, we see dehydration of the objects. This causes the objects to shrink and more stress occurs. Therefore, in a fluctuating temperature and relative humidity, the object expands and contracts repeatedly. This constant movement within the object will cause increased stress at its weak points. Here, the constant expansion and contraction of the vellum resulted in complete separation of the material at the point of highest stress, the line where the spine was stressed during the opening and closing of the book. Most objects are mixtures of materials, and each material has its own rate of expansion and contraction. Therefore, when the object reacts to a change in relative humidity, each material can move in different directions, causing stress, cracking, and finally delamination of one material from the other. This portrait miniature is a fine painting on ivory. The ivory was placed in a metal and glass case. The ivory expanded more than the paint, causing the paint to crack, and upon contraction, causing the paint to delaminate. The ivory also expanded more than the case materials, forcing the painting to split down the center in much the same way as the spine of the book. This object is a photograph, which has been printed on paper which has a grain direction. Here the paper has expanded and contracted across the grain, which has caused the emulsion of the photograph to crack in many small parts in that direction. All materials deteriorate. What type of material is this object made from? It's not metal, leather, or ceramic. It is glass. This object was deteriorated and has a layered structure of red and green glasses, each having a different chemical composition. The red and green glass expand and contract at different rates, which in the end has caused the green glass to separate from the surface of the red glass. Or how about the materials that museum people put on objects? Do they cause deterioration? Sure they do. Here we see an iron paper clip on a cotton cuff. The iron clip corroded during a period of high relative humidity, and the corrosion products that penetrated the cotton caused both a physical and chemical deterioration problem. First, the corrosion is acidic, which caused a weakening of the fibers. Second, the corrosion is more rigid than the cotton. The corrosion expands and contracts less than the cotton. So eventually, the corrosion area will disengage from the cotton as it responds to the environment. And as you may have already guessed, light speeds up this process. Another good example of this physical problem is this flag. Here the painted letters are disengaging from the rest of the silk flag because of the difference in the rate at which the painted silk and the silk expand and contract. Or how about this fabulous Navajo rug? The owner rolled the rug, which was not a bad idea, but secured the rug with a heavy string. The string expanded and contracted less than the rug, so the string acted as a saw, cutting the rug as it expanded. Finally, it is important to make this point very clear. Photographs are extraordinarily sensitive to moisture. Here is an albumin print, which has faded due to moisture contact from the paste behind the paper. The paste absorbs moisture from the air, even after it has dried, keeping the print slightly wet. This is why the fading follows the pattern of the paste and appears like brush strokes. What are the goals in protecting objects from the effects of temperature and relative humidity? And what can you do to achieve them? First, minimize changes in the temperature and relative humidity. How? Monitor the environment to find out what type of climate you really have. You can buy a variety of equipment and spend anywhere from $1.50 to $500 for it. Log the temperature and relative humidity of each gauge, along with the time, date, and location of the meter in order to develop a record of the data. Once you have done this for a year, you will get a much better idea of what the environment is really like. Since all materials expand and contract at different rates, they require different storage and exhibit environments. Metals, for example, require a very low relative humidity to prevent them from corroding. The temperature of 68 to 72 degrees Fahrenheit with 50% relative humidity has been chosen by experts who feel that fewer bad reactions happen to a greater number of materials in this range. However, the single most important factor in all of this is to keep the relative humidity as constant as possible, with major consideration given to your local climate in order to prevent the objects from undergoing these stressful expansion, contraction movements, and chemical changes. This will also minimize the potential for mold growth. Ways to reduce fluctuation include installing a humidistat on the air conditioning and heating system. The humidistat measures humidity and will cause an immediate correction if any fluctuations occur. Purchase equipment to properly humidify or dehumidify your collection. Some of these machines have humidistats and do both functions. Avoid displaying or storing objects on an outside wall of your building, near air conditioning and heating vents, fireplaces, or in drafts. Do not turn down the heat at night. This will cause tremendous fluctuations. If your institution is undergoing construction, ask for a vestibule to be part of the plan. A vestibule will reduce the fluctuations of the environment as the doors to the outside are opened and closed, because the vestibule creates an air mixing area. If the doors are closed tightly, this space will function even more efficiently. Also, ask for the temperature and relative humidity controls to be zoned so the storage, exhibit, and work areas are on different control gauges. This will allow for a more efficient management of the environment. And last, if your museum does not have proper environmental controls, you should design storage and exhibit cases so they are tightly sealed, creating a small environmental chamber. This microclimate will become a barrier to the larger environment. Cases can be designed in many ways to allow for climate control and proper ventilation. Dust and dirt are probably the most common but most underrated agents of deterioration. Most people think that dusting is a simple operation, but as you may have already guessed, dust is an exceptionally difficult agent to control. Dust is abrasive and will scratch the object irreparably if vigorously removed. Sometimes the dirt can be cleaned, as with this gourd. However, the cleaning was so complex, it took the same time to clean it as it did this 3.5-foot sculpture. Sometimes objects cannot be cleaned at all. This Egyptian mask is permanently damaged. The dust and dirt which collected on the surface has the same solubility as the paint. It is impossible to clean the dirt without removing the paint. Another form of irreparable damage is shown on this stone. It had a label placed on it, probably in the 1920s, by a museum staff person. Dust and dirt collected on the surface and became ingrained in the porous structure of the stone, but not under the label. The result is the original color of the stone is lighter than the areas around it, which have become darker due to dust accumulation. You can see the irreparable damage done by this discoloration. Dust is not only a host for pollutants, it also attracts moisture from the air. The pollutants can come from car exhaust, local factories, and cooking or smoking byproducts. The pollutants then become involved in chemical reactions precipitated by the moisture in the air, which is drawn to the dust surface. For example, someone touches a metal object and leaves a fingerprint on it. The fingerprint is an oil deposit and will not dry. The dust and pollutants then land on the oil deposit and are held in place. As the relative humidity goes up and moisture collects in the air, the sulfur dioxide from car exhaust becomes sulfuric acid. This acid then etches the metal, permanently engraving the fingerprint on the object. Here is a painted frame with the same problem. The metal paint has copper in it, so the acidity in the air interacts with the copper, forming an engraved fingerprint in the paint layer. A proper storage for silver is to put it in a polyethylene bag with some silica gel to keep it dry. Your goal here is to prevent dust and dirt from collecting on the objects. This can be done in many ways. You can filter the air entering the exhibit in storage spaces. There are large filtration units that can be connected to the heating and air conditioning system, or more modest means involving the addition of furnace filters and pollution-absorbent materials in all vent openings in the galleries and cases. The objects should be kept in cases while on exhibit or in storage. These cases should be tightly sealed to prevent dust and airborne pollutants from entering the case. However, you must remember that the objects are going to deteriorate some, and you must provide a vent system to flush these byproducts of deterioration from the case. It is therefore critical that the case be made from very stable materials to reduce the risk that they will deteriorate and leave gaseous byproducts in the case. Case vents should always have pollutant and dust filters. These filters were in the case for only 8 months. Next, you must minimize abrasion due to dust accumulation. Objects should be carefully vacuumed using a screen and a low suction vacuum. This will pull the dirt away from the object instead of grinding it in. Objects should also be handled with cotton gloves to prevent the deposit of fingerprints into the porous structure of the material. Paper, ivory, textiles, and metals are examples of materials which should not be handled with bare hands. If you have loose or fragile surfaces, cleaning should not be attempted. A problem that you all have is the use of non-archival materials in the collection. These inferior materials are usually associated with the object long before you get them and can be easily overlooked for more pressing projects. They are not innocent, non-reactive materials. Quite the contrary. These materials can be very harmful. Generally, old mat boards and framing supplies are made from wood byproducts. These woody materials are quite acidic because they contain lignin, an acid material in the tree. The acidity will migrate from the framing materials into your object, burning, staining, and embrittling the object until it can no longer bear its own weight. Furthermore, many paints, varnishes, and decorative exhibit materials like these contain sulfur, chloride, or formaldehyde, which react with water to form acids which will affect your objects. Paper objects are also very often attached to framing materials with pins, waxes, tapes, or glues. These materials will penetrate the object, often never drying, causing permanent staining. Beyond that, these materials are often used to install objects in cases. They will not withstand vibration and will let objects fall. The proper choice for framing, treatment, storage, and exhibit materials are those which are acid-free, lignin-free, sulfur-free, formaldehyde-free, and chloride-free. This may seem like a very restrictive list, but it really is not. For example, there are a number of companies that sell archival materials for storing your collection. Here is a simple photography storage system. There is a drop-front acid-free box with folios made out of unbuffered, acid-free paper, folded and cut to size to hold the objects. The photographs are then interleaved with unbuffered, acid-free tissue paper. The box and paper cost about $10 per box when filled. Here is a simple way to frame a photograph. The object is held to the back mat with acid-free paper hinges secured with acid-free linen tape. Notice that the paper tape never touches the object. Very often, wood is used for exhibit and storage cases. Wood contains a high level of acidity and must be coated with materials to restrict their migration. Plywood, plastic laminates, and masonite have acidic adhesives, which also require coating. Several coats of an aluminum-based roof paint or shellac are appropriate coating materials. Another storage problem is unstable synthetic materials. Commercially available synthetic materials are made plastic or flexible by the addition of a plasticizer. This can be a thick, molasses-like material which is added to the plastic to allow the molecules to slip over each other and therefore become more flexible. The problem with these plasticizers is that they come out of the synthetic material and deposit on your objects and leave the plastic material brittle. Your objects will then attract dust and dirt and will become a platform for chemical reactions to occur. The final result is a deteriorated, sticky, brittle object like this hide quiver. Polyvinyl chlorides not only give off plasticizers, but free chlorine as well, creating hydrochloric acid in a high relative humidity. Now, the last bit of bad news about these plastics is that they have a moderate static electric charge, which will draw dust and dirt to them. Therefore, you must select synthetic materials you use carefully. If you must use a synthetic material, use polyethylene, polyester, polycarbonate, acrylics, or polypropylene. These are all available from local packing, material, and conservation supply houses. Your goals in selecting appropriate storage, exhibit, and treat materials for your objects are very simple. First, you must evaluate all materials to determine if they are free from acid, lignin, sulfur, chloride, and formaldehyde. The method for this examination is to read the product literature provided by the manufacturer. If nothing is provided in writing, find another product. It is imperative that you do not risk the object's safety. If you cannot find a suitable material, call your colleagues or conservators for advice. There are also several easy-to-use kits that test for acidity and can be purchased from conservation supply houses. Remember, all of your materials must be safe. These include storage boxes, tissues and papers, case construction materials, adhesives, paints and display fabrics, and installation materials. Please remember how important this selection is, and that if you have any problems with relative humidity or light, it will compound the problems of these materials. Creating a safe environment for the object will help reduce the risk of deterioration. This slide of an African sculpture which has been attacked by wood-eating insects reminds me of an extremely important agent of destruction in your collection: pests and insects. This problem is not static, but can be an ever-increasing one in your collection. A moth, silverfish, or rodent in your collection is generally extremely difficult to get rid of. Or here, where a moth ate only the wool, leaving the silk untouched. These pests and insects eat your collection and then deposit their eggs for future generations to do the same. They are mobile and will spread very quickly. Museums used to think that fumigation was the answer, but now scientists are finding that fumigation chemicals are unsafe for the object and the staff who handles the objects long after the collection has been treated. The emphasis now is on preventative maintenance of the collection. You should not allow eating, drinking, or smoking in a collection area. All of these provide foods for for the pests or insects. All objects should be carefully vacuumed to remove live insects and eggs before being stored in the collection. To prevent contamination of the storage area, preparation for storage should be done in an area separate from, but not in, storage. Discard all old packing materials the object arrived in. These are great food sources. And probably most important, vacuum and sweep the storage and exhibit areas regularly. This will remove food sources and will also remove dust, which insects love to nest in. And as you may have already guessed, a properly controlled relative humidity will not only deter mold, but silverfish and roaches as well. Many people have asked me to suggest a manual on the handling of objects. The only way to have a safe handling procedure is to understand deterioration. With this knowledge, you are able to determine where to look for stress points and possible areas of weakness. You are sensitive to color changes and the significance of these changes to the overall stability of the object. You are aware of the potential dangers in lifting an object without examining or testing it before you do. Here is an example of a wonderful hat that was lifted from a table by the top. What happened? The top disengaged from the brim. Why? Because the hat had sat on a storage shelf bearing the majority of the weight around the perimeter where the hat broke. If the staff person had looked at the object and then carefully examined it to see if there was a problem, this would not have happened. Your goal in handling is to take the care needed to prevent damage. If an object must be moved, you should have an adequate supply of appropriate support materials for lightweight objects, cotton gloves, padded carts, baskets and trays for heavier objects. If you are dealing with a large object, you should have enough time and enough people on hand to do the job properly. Even a small object should be very carefully lifted to determine its center of gravity and to assess any damage before it is moved. Two common sense rules are: never lift an object by its handle or its rim, and always use two hands supporting the object from above and below. Finally, the principles of proper handling should not only be made plain to the entire staff, but to the public as well. This will help to explain why objects are in cases and behind barriers and should not be touched. What we have seen is that the deteriorating agents of the environment are all interrelated. We have seen that heat and moisture operate together to damage the molecular structure of the objects. We have also seen that inferior quality materials placed near your objects will interact with the environment and also cause deterioration. The process of deterioration is dynamic and can cause irreparable damage to your objects if no attempt is made to control it. But control is within your ability and budget. It is not an expensive process to unframe your objects, separating them from inferior quality materials. It is also not an expensive project to monitor your climate to determine what type of environmental controls you need for the preservation of the collection. What is expensive is to avoid thinking about these problems. Let's review our goals and try to remember that these goals are achievable. They are: to minimize light levels, to minimize the time the object is exposed to light, to minimize the level of ultraviolet and infrared the object is exposed to minimize the fluctuations in the temperature and relative humidity, to minimize dust accumulation and establish safe cleaning procedures, to carefully select and use only stable archival products for the storage and display of your collection, to implement safe handling procedures, to control pests and insects. Good luck, and if I can be of any further help, please give me a call.